Hello everyone, welcome to today's video on Newton forward interpolation. In this session, we will learn the example for Newton forward interpolation. Let's get started. Before we jump into the example, let's quickly refresh our memory about this forward interpolation method. It's the type of interpolation where we have to find the values between the data points using the polynomial equations, and it's called forward because it uses the data points from the beginning of the data set to estimate the values ahead of them. That means that the value which we have to find will lie somewhere near the base value, that is the first value of the given data table. If you want to know more about interpolation and forward interpolation method, then watch my previous video in this playlist. I will also provide the link in the description box. Now let's see its working. We will be given some data points which are equally spaced. This is the prerequisite condition for this method. Next, we will construct the forward difference table. It will look like this. Here delta, or this small triangle, is known as the forward difference operator. This table will be used to find the polynomial equation using the Newton's forward interpolation formula. This polynomial equation will then be used to estimate the values between the data points. Now let's see this working by an example. The question is, we have to find y 1.5 from the given table. Let me write this table in a vertical format. Now we will construct a forward difference table for the given data. First, let's write the values of delta y. Here delta y1 will be 3 minus 1. Next delta y2 will be 11 minus 3. Next delta y3 will be 31 minus 11. Next will be 69 minus 31. Next will be 131 minus 69. Next will be 223 minus 131. If we solve these, we will get delta y. So we will get delta y as 2, 8, 20, 38, 62, 92. This delta y will be used to calculate delta square y. So the first term of delta square y will be calculated by 8 minus 2, subtracting these two. Next will be 20 minus 8. Next will be 38 minus 20. Next is 62 minus 38. And the last one is 92 minus 62. Solving this delta square y, we will get 6, 12, 18, 24 and 30. So delta cube y will be based on delta square y. So first term will be 12 minus 6, that is 6. Next is 18 minus 12, again 6. Next is 24 minus 18, again 6. Next is 30 minus 24, again 6. Now we will calculate for delta raised to the power 4y. 6 minus 6 will be 0. Again 6 minus 6 will be 0. Again 6 minus 6 will be 0. As all the values are 0 in delta raised to the power 4y, so we can stop finding the differences here. That means we don't have to calculate delta raised to the power 5y, as we have already obtained all zeros. So this is the final forward difference table. Next, we have to use the Newton's interpolation formula to construct the polynomial equation. Here a was the base value, h was the distance between two consecutive data points, and u was x minus a divided by h. From our forward difference table, you can see that the base value of x is 0. So a is equal to 0. Next, we have to calculate the value of 1.5. This value lies near to the base value, So we can use the Newton forward formula here. So x is equal to 1.5, and now we have to calculate for h, which is the distance between two consecutive data points. Here you can see that the distance between two consecutive data points is 1. So h is equal to 1. Now we will calculate u. So u is equal to x minus a divided by h. So we get u is equal to 1.5. Now we have to put all these values in the Newton's forward formula. Additionally, in this formula, we need the values of y naught, delta square y naught, and delta raised to the power n y naught. We will take these values from the forward difference table which we have calculated before. So in the Newton forward interpolation method, you will use the y naught as 1, delta y naught will be 2, delta square y naught will be 6, delta cube y naught will be 6, delta raised to the power 4 y naught will be 0. So we have to put all these in the Newton's forward formula. We'll get y 1.5 as this. Solving it further, we will finally get y 1.5 as 5.875. So this is all. In the next videos, we will solve more examples related to this method. We will also cover other related techniques. So stay tuned for the upcoming videos. If you have any doubts, then you may ask in the comment section. Thanks for watching. Don't forget to like, subscribe, and hit that bell icon for more such videos. Have a nice day.